So is everybody here for the Grasshopper workshop? Yep. An introduction to Grasshopper. Perfect. Are you guys also here for the Grasshopper workshop? Amazing. And you can come closer this way if you want to use these computers. You'll be able to hear me better. Um, anybody else? Is everybody else? Are the guys over there? Are you here for the Grasshopper workshop? Are you here for the Grasshopper workshop? Yeah. Just listen. Okay, perfect. I'll be expecting good things from you at the end then. So we'll get started then with today's workshop. So as many of you know, as most of you have been here before, my name is Joe Cook. I'm one of the lecturers here at the Manchester School of Architecture in the ADD team. And what we're going to do today is we're going to do a quick introduction to Grasshopper and give you some key skills that are going to get you started in understanding parametric design and Grasshopper itself. One of the main things that we're going to cover is Grasshopper and how we use Grasshopper within Rhino. So we're going to record this session and we'll put it online later so that you'll be able to access this through the ADD Moodle page. And if you just click on the workshops and then the poster of today's workshop, we'll replace the link to the workshop with the link to the recorded video. Okay, perfect. So let me just make sure that the screen is on. Bear with me. Perfect. Okay. So how many people here have used Grasshopper before? Yeah. How many of you have attended workshop? I think you've attended some workshops here before. So we're going to get started with a brief introduction to what Grasshopper is and how it came about and how it came to be, and then how we can then use it. One of the main and most crucial and important things to learn is why this is important for you as architecture students. Okay, I've been teaching Rhino and Grasshopper for many years. So I started teaching it back in 2010. So it's been about 15 years that I've been teaching Rhino and Grasshopper. So I'm going to go through the very, very, very basics. Before I teach you about Grasshopper, I want to teach you something about Rhino first and foremost. So as a precursor to Grasshopper, this is one of the most important tools that existed before Grasshopper came to be. So Rhino was a tool that was used and has been used quite extensively within the 3D modeling industry. And as a precursor to Grasshopper, there's this little button down here, which is called Record History. And I'm going to just briefly explain to you how that works. And that will help you to understand how Grasshopper works by understanding this. So in Rhino, when I create some geometry, so for example, I'm going to create a curve like this one here. And if I extrude this curve, and I bring this up, you'll see that I now have a surface from the curve that I just created. Now in Rhino, everything, when we create something new, it keeps the previous geometry that was created. So even though I've just created a new surface, it will keep my curve here. So it's just adding more geometry on top of the other geometry. It doesn't replace the curve. It keeps it there. Now let's say, for example, I'm not happy with this surface. If I go back to my original curve just here and I select this and I move it, I would need to extrude this curve again in order for me to update that geometry. Now, in Rhino, what I could do to save me from having to do that, when I create my original surface, if I turn this button on here, which is called Record History, I'm just going to turn that on, and then I'm going to extrude my curve. If I want to now manipulate this curve, you'll see that it updates my surface with it, because it's recorded the history of that command. And so this was like a precursor to Grasshopper, because it allowed us to remember certain data, and then it remembers where the curve was that the surface came from. And then as I move that curve, it updates the surface. And this was like a precursor to the way that Grasshopper functions. So a person called David Rutten developed Grasshopper then as a tool that stores data, but then we can visually see it. So rather than in Rhino, if I wanted to go back and see this information, I would need to expand my my command line here. And this is just all of the different commands that I've run in Rhino ever since I opened it today. And it gives me just all of the different commands and a history of all of my commands. So as a precursor to Grasshopper, that's one sort of idea about how data and remembering data, so then we can update data. And then we can show you, I'll show you how then that applies to Grasshopper and how we can visually see how that data is structured and how we can work with it. So in order to open up Grasshopper, what we need to do is we can either type it in our command line on the Rhino interface. I type Grasshopper and press enter. Or we can go to the Grasshopper icon just here, launch Grasshopper, and we can launch the Grasshopper page just here, and you should open up an empty document. Okay, so that's how we open up Grasshopper. Now, when I'm working with Grasshopper, what I typically do is I will split the two different interfaces just straight down the middle on my page. So because we have two different interfaces, we've got our Rhino interface here, and we've got our Grasshopper one here. I'll just drag the Grasshopper one to the right and my Rhino interface to the left, and just snap it to the left, and then it will just share the screen. Now, if I move this in the middle of my screen, you can adjust this as you will, but if you snap it here, it'll go direct to the middle. Okay, so I'm just going to create some interface or some real estate for myself. Then what I typically do is I'll expand the perspective view because I want to really mainly work in the perspective view, which is just here. So that's the first thing that I'm going to do when I open up Grasshopper. Now, the way that Grasshopper works is that it will create different types of data that we can work with, and I'm going to share with you what those different types of data are, how we understand what they are, and then how they then shows or within our interface within Rhino. So what I'm going to do here, I'm just going to open up a file that I've prepared. And what I'm going to do here is just show you basically the principle of parametric modeling and how we can use Grasshopper in this way. Now, I have to give a shout out to some really amazing resources online because I have a lot of different resources that I use for my Grasshopper scripts. And so if I just share with you what a couple of those are. So one of them, which has really helped me and I use quite a lot within my own teaching, is Think Parametric. So you can make a note of this. And Think Parametric was a really great resource when I first started learning Grasshopper. It's one that I use quite a lot, and it's one that I'll use some of the tools that they share in there in my own teaching quite a lot because they've got some really amazing resources. So this is a really good tool that you can use for Grasshopper. There's another one also, which is Parametric House. And this is a resource that has just lots of different Grasshopper scripts that are already created, and they're applied to just different contexts. So, and they're rendered quite minimally, so you don't get caught up in the actual design. You're getting caught up in the actual functionality of what Grasshopper does and how it does it. So this has like quite a lot of resources as well. They've got YouTube videos and some scripts that have already been built. So you can use those. They do have a free tier and they also have some paid functionality. But these are just some really useful resources that I use in order to download scripts or use scripts or learn about new scripts or learn about the different principles of a parametric design in Grasshopper. So they're just some different resources that we can use. And one of the resources from Think Parametric is this one here, which it just tells us about what the difference is between parametric modeling. So when we're talking about parametric modeling or parametric design, does anybody know what that means? Like parametric design or parametric modeling? Does anyone have an idea what parametric modeling is? Or want to hazard a guess? Any thoughts from anybody? Yeah, based on variables. Great. So the variables could be different parameters that we use and different variables that can inform our design. So an example of this might be that I have 4 different ellipses here that I've lofted. And if I want to adjust those ellipses, I can do, and then create different design iterations of the same design. You know, for if you're doing like product design, vases, or if you're doing towers in parametric design. And I'll show you how we can do something like this very quickly and easily as our first parametric model. So I'll take you from scratch in how we can do something like this. But before I do that, what I wanted to do just very quickly was just show you, if I just move this to one side. Just bear with me. There we go. I'm just going to open this up because I want to just show you very quickly the different parameters within Grasshopper and its interface. So before we get started with actually modeling anything, I just wanted to quickly go through with you what the different icons are or the different nodes are within Grasshopper and how we use them and the workflow. So one of the first things to know is about parameters. And the parameters are here in this tab, which is params. So over in our Grasshopper interface over here, we have a menu bar along the top. And in the menu bar, this is where we can start to create different new files, and we can save our files. We've got edit, where we can use some of the edit functionality. We've got different views and then different displays. So the different displays are here, and I'll show you how we can use those different displays and what they mean. So if I do draw icons, what it will do is it will draw an icon instead of having the text. Now, when you first start out in Grasshopper learning, I recommend that you keep the words on there and you let it tell you what is in there, just so you remember. Because sometimes it's hard to remember just by a graphical icon exactly what it is and what it does. So if you wanted to change that, what you can do is you can go up here to display and you can turn draw icons off and it will replace it with the words. And then you can follow along a lot more easily. Within the display as well, we can do draw full names, and we can turn that on and off. If we don't do draw full names, then what it'll do is an abbreviated version of what that is. But if we do turn draw full names on, it will turn on the full names of the different properties. Just a quick note. When I'm dealing with parameters, this is something that is collecting data. So it's something that is holding data. So let me tell you what I mean by that. Anything that has a hexagon on it is a parameter that is holding data. So in this instance, this here, if I hover over it, this tells me this is point information. So I can only put points inside of this. The next one, for example, is curve information. So it can only hold curves. So I can't put points inside a curve parameter because it's for curves, and so on and so forth. The same with like brep. Now, when we're talking about a brep, we're talking about solids or anything that has a boundary on it, and we call those breps. So you're going to have to get used to some of the terminology because it's going to change a little bit, but you'll get used to that as we go through it. So if I turn the full names, the icons off and just turn the full names on, I just wanted to tell you that anything that has a hexagon is holding information. It's parameters. And if I just show you, if I just turn this off, I'm just going to right click on there. And if I want to turn anything off within my Grasshopper interface, anything that I create in Rhino will appear here in that in Grasshopper, sorry, will appear here in my Rhino interface. If I want to turn that off so I don't see it, I can just select any of the items. I can right click, I can do preview off, and it won't show me anything there. So these are the different parameters. Let's say that I have a point in Rhino that I've drawn just here, and I want to contain or reference that data from Rhino in Grasshopper. What I can do is I can go over to this point here, I can right click on it, and I can do set one point. And I can then reference that point by selecting it. And you'll see now that it's turned from orange to gray. Now, when it's orange, it usually means that there's an error or a warning or an issue. And if I want to know what that issue is, I can go to the top right-hand side of my node, and it will tell me what that issue is. So here it's saying curve failed to collect data. So there's no data being referenced. So I referenced a point just now, and so it got rid of that, and it said now it's got data. And if I want to check that, I can just hover my mouse over it. I'm not going to click anything. Just hover your mouse over, and you can see one locally defined value, a reference point. So I've referenced a point in here. So now I can use that data within my workflow. And data always flows from left to right. So I'll explain that to you in more detail as we go through. Just very quickly on that note, these are the different colors of the different parameters. So light gray means it's visible, enabled, and there's no errors. So if I just turn this on and turn the preview on, light gray means it's visible and it has no errors. If I turn it off by clicking on it and right clicking above it and do preview off, dark gray means that it's not visible. Okay, but it's enabled and there's no errors. Orange means that there's a warning, and if you want to know what that warning is, again, we can just go to the warning icon above the different node, and it will tell us what the error is that we're getting. Red is a warning and an error that is slightly different than orange, and if I hover over this, what this is saying is that the data conversion failed from text to number. So it's expecting one type of data, but we're putting in another one. So an example of that would be if we were to put points into the curve parameter. So if I go here, right click on here, set one curve, and I select that point, it won't let me do it, and it won't let me put that data in. If I then brute force it and say, okay, well, I'm going to put this point in here, that's when it'll error out. So I'm brute forcing it and saying, well, I'm going to take that point and I'm going to put it into the curve. Then it'll tell me the data conversion failed from point to curve. It doesn't know that data because it's going from point to curve. Okay? Hopefully that's clear. So that's a red error. A faded gray means that it's disabled. So if I go on here and I click enabled, I've now disabled it and means it's faded gray, which means that it's no longer enabled. So nothing will work as it comes through that. If I right click on it again and click enabled, I can just enable and disable it. If I right click on it again, I can turn my preview on and I have this little help icon here, which allows me to get help on what the icon is, what it does, and then what the input parameters are and what the output parameters are. So that's just a really useful little tip as well, that if you're ever struggling or you don't know what something is, then you can just right click on it, click on help, and it will just pop up this Grasshopper help information and tell you exactly what that parameter does. This is especially useful if you're like downloading different scripts, or if someone else is giving you a script, the Grasshopper scripts that you've never used before, and you're like, oh, what does that do? You can just go to the help and it'll tell you. Also, another little handy tip is in our interface, if I hold Control and Alt and then click on a node, it will tell me exactly in my menu bar where to find that. Okay, so it will tell me in my menu bar where I can find that node. So if you want to have a test of doing that, yeah, just drag a parameter on, or it doesn't really matter what you drag on onto here. You can just drag so something from parameters, you can just drag it onto your canvas. And if you hold Control Alt and then left click, it will show you exactly where to find that in your menu bar, which can be really useful, especially if you're downloading different scripts. If something is light green, that means it's the selected component. So when it's green like this, it means I have that selected right now. So I've selected it. Okay, hopefully that makes sense to everybody. So these are the different components, and they perform an action based on your input and the output a certain result of that action. So let me give an example. Data always flows from left to right. So I have my inputs here and I have my output here. So an example of that would be like the addition. So what I would need to do is put a number here, and then it will give us an output. And it's all happening here within the interface. So if I put that to the test, what I could do is I can input data in different ways. I can use a number slider here, or I can use a panel. But if we're using numbers, what I typically do is use a number slider. So if I just was to go here to parameters, what you can do is you can follow along with this as well if you want. You could just double click on here and type addition, because that's another way that we can access very quickly our commands. So we can just double click on our canvas because we don't know where everything is, and we can type addition and then it'll just bring up addition. And then you can just drag that into here. Okay, and now what I can do is I can use a number slider, which is on here. And there's different ways that I can bring a number slider into my interface. I can either just go up here to the parameters and I can drag it from the input, and then you see that it's just there. Or there's another way I can do it. I can double click on my canvas and I can just start typing a number. And it can be any number that I want. I can just type 10 and press enter, and then it will bring a number slider with the maximum amount of 10. And the way that the number slider then works is I can move up and down this number slider. And I can put that inside here. And then I can just copy and paste that. So I can do Control C and Control and V. And I can just bring that one into the second. And if I want to check what my output is, I can either hover over here, and it says that I've got one locally defined value, so I know that I'm outputting some information, but I don't know what that information is just yet. I can then use one of these panels, and I can just bring that here. And if I just plug this output into this input, it will tell me that that is 2. And now if I hover over again, it's saying that it's 5, and I can see that it's 5. So it's doing 4 plus 1, and it's outputting it as 5. And that's how data works in Grasshopper. It flows from left to right. And then within these components, it then performs a function and then gives us an output. And that's how we start to then build up a computational logic. Because then we can use that, we can use our output and use that as a new input for something else. And that's how we create logic. So I've showed you how to do number sliders. I've showed you how to use the panel here to check our output. I've showed you how we can bring information in very quickly. Let me just show you on the number sliders how the number sliders work. So if I wanted to adjust this number slider, I'm just going to bring this across. So the other thing that I can do, I can select any of my nodes and I can drag them across in this canvas. And this canvas is huge. I can scroll out and I can scroll in. And I can just move this to anywhere on this canvas. And now you can see the different input and output data that I have. And if I want to change my number slider, what I can do is I can just double click on the number slider and I can change that number just here. So if you double click on the number slider, you can change the max and minimum just by double clicking on it. So if I want the maximum of this to be 100 instead of 10, I can type 100 and then I'll press this little green tick here. I'll click OK. And now my number slider has gone from 10 to 100. If I want to have like decimals in here as well, so if I want it to be very precise numbers, I can also do that. I can double click on here. And what I can do is I can then change the number of digits by going here to floating points number. And I can change the number of decimal places by just dragging this up and down. So if you're working with very precise numbers, that you need very precise numbers, you can do that by just going on floating point numbers, and then you can increase or decrease the number of digits. Okay? That makes sense to everyone? Yep. Great. So now that I've showed you how to change the number sliders, I can also do minus numbers as well. So one of the things that I can do here is in my minimum, I can just double click on that and I could type minus 100. And now what it will do is it will take this slider and allow me to go the midpoint being 0 here. And then as I slide left, it'll give me minus numbers. And as I go right, it'll give me positive numbers. So I can also work with negative numbers as well, which can be useful if I'm working in 3D space. If you think about how 3D space works, we have the X, Y, and Z coordinates. So the X, Y, and Z coordinates, the way that they work is they'll go right, they'll go up, they'll go left, and they'll go in the Z axis, which is going straight up. So if we think about that, this number here where they converge is 0, 0, 0. So anything to the left-hand side of that becomes a negative number. And anything to the right-hand side is a positive number. So when we're working in 3D space, we sometimes need negative numbers depending on where we're working in 3D space. And sometimes we need positive numbers depending on where we're working in 3D space, because we're always plotting things in 3D space. And everything has a point in space and a number. 0, 0, 0 being the absolute center where all those points converge. So negative numbers is something that we often will use. Okay, so these are just some of the different components. So we have mathematical components, things that can perform mathematical functions. We have curve components. So if I go up here on my tabs, you see I've got mathematical components here. I've got set components here. I've got vector components here. And then I've got curve components here. And this is anything relating to curves. Usually you'll find within the curve components. We have surface and polysurface components, which are just in this tab here. And then underneath, we start to then group them together. So we've got analyze, freeform, primitive, sub-D, and utilities. And so that gives you an idea of some of the different surface components. And then we also have mesh components as well that we can use. And so we have different components in Grasshopper, and I'll show you how those work. So when we're dealing with component parts, this is the structure of how component parts work. So on the left-hand side, we have our input. So for this ellipse, for example, it's asking for a plane. And if I hover over that, it'll tell me that I need to define a plane. It'll ask me for radius 1, which is the first length that it's going to be on our ellipse. And then radius 2, which is the second length of our ellipse. So I need that information in order for me to create an ellipse. So if you want to practice doing that, what you can do is just double click on your menu bar, on your navigation bar, sorry, and just type ellipse. And it's going to be this one here in orange. And then we can bring this ellipse onto here. But right now there's no data on here. I'm just going to give a preview. There's no data that's being contained within this ellipse, so it's not creating an ellipse right now. So we need to start inputting some data into here in order for us to then output our ellipse. So we need a plane. By default, if I just hover over that, it's telling me that it's actually already defining our plane as one locally defined value, which is the world X and Y. And Grasshopper typically will just revert things to some default geometry or some default planes or default vectors, just to save you from having to input that every time. So by default, it's just saying, I'm just doing it on the world X and Y plane. For radius 1, we need to specify our first radius. So if we just double click again and we just type a number, we could just type 100, for example. We can put that into our first radius, and that's going to then give us our first radius. And then I can copy and paste this, Control and V. I can put that into my second radius, And I might need to zoom out if you can't see it. And then you can see that I can now change the parameters of this radius, and I can change the size of my ellipse. So this is now a non-destructive workflow that allows me to update and change the parameters of what it is that I'm creating. Okay, so now I have an ellipse. So what I can then do, as my data is flowing, because my output then is on the right, I can see here that I'm now outputting one ellipse. If I want to check that, if I go to my parameters and put a panel there and just drag that on, I can just see that it's outputting an elliptic curve. And that's telling me what it's outputting. So I can see that I'm outputting an elliptical curve. We also have two other outputs. One is focus 1 and one is focus 2. And what that's doing is it's telling me what the different the coordinates that I'm using. It's telling me what the focus is of that. And it's 74 right now. 74.23. And again, I can just change that and see that that's, and as I update this, you'll see that it'll change just there. So that's how I output data that I can then use for something else. So for example, let's say now, using the example that I used earlier, where I created a curve in Rhino and then I extruded it upwards. Let's say we want to extrude this ellipse upwards. I can now use the data that I've created and extrude that upwards. So if I wanted to do that, what I can do is I can double click here on my interface and I can type extrude. And then if I just bring an extrude node in, I can then take my ellipse and I can bring it into my base. Okay? Now, one of the issues that we see happening here now, as I bring that ellipse into my base, is it hasn't done anything because it doesn't know which direction it wants me to go or which direction it wants me to extrude. So I need some more data input for me to make this to work. So the direction here, if I just hover over that, it will tell me what I need. So it's telling me that I need a direction in order for this to work. In order to specify a direction, I need to use a vector. And the way that vectors work is they allow me to go or specify X, Y, and Z directions, which are just here. If I go to vec and vector, these are all the different vectors. Does anybody know what a vector is in mathematical terms? Does anyone know what a vector is? Did you want to say something? Do you want to hazard a guess? Yeah, a direction. So in this instance, we've got X, Y, or Z. The vector is essentially the direction that I'm going to be moving this in. So in this instance, what vector direction do I need in order to bring it upwards? Z. So I'm going to bring a unit Z in. So I'm going to either drag that in, unit Z, or another way that I can access that, if I double click on my canvas and type unit Z, I can also find it that way and just bring that in. And then I'm going to bring that into my direction. Now, what you'll see happening here now is extruded it, but it's extruded it by an amount of just 1. So if I want to be able to control that, I need to put a number slider in. And so, again, I can either copy and paste one of my number sliders here, or I can double click on my canvas and I can just start typing a number like 100, press enter, and I'll bring in a new number slider, and then I can just drag that in, and now I can specify the height of this extrude. And that's how my data works. So I'm always using input data and then outputting something. Sometimes I need multiple levels of data to input for it to work. In this instance, I needed the ellipse, but I also needed the vector or the direction that I wanted that ellipse to go in. And now it's output some geometry. Okay? Any questions about that? Has everyone been able to follow along with that? Does it make sense? Everyone clear? Wonderful. And there's also lots of other different component parts. And So the different parts here, if I just click on here, if I hover over it, it will give me an idea of what's contained within here. If I double click or if I right click on here, it will give me the options to be able to preview, enable, bake, or help. And again, I can see what this does. If I have different input parameters, I can also hover over those and right click on them, and then it will give me different options that I can use for this data that's being brought in. And if I don't know what something is, for example, for the base, I can right click on it, and they've got this tool that's got extract parameter. And what that will do is it will extract out what kind of data it is that I need, which can be useful. In some instances, for example, if it's a number, so for example, this factor here, you'll see, I'll just right click on there and I'll extract parameter. It's just going to tell me it's a factor. So I'm kind of like doubling up my information there. So in that instance, it's not brought out a number slider. It's just bringing out a factor. But I know that I need a number slider for this one. For the plane, for example, I can right click on that, extract parameter, and it'll tell me that that's the plane that I need. But that's just a useful little tip if you want to just like visually see how the data is being structured, and then you know exactly how you can use that data. Now I can adjust this, and as I adjust my original ellipse, it'll also adjust my extrusion. So this is your first principles of parametric modeling. And that's how parametric modeling works. If I just show you that we have some also dynamic components, and the way dynamic components work is they will perform a function within them, within here, and then they'll output certain data. So this can be dynamic. This will take different information that's input and it will output it just there. So if we just look over here as well, I'm just going to show you very quickly. I'm just going to open up another file and I'll show you about the different wires. But before I do that, does anybody have any questions so far about anything? No? Everyone able to follow along? Great. So I just wanted to quickly share with you how the wires work in Grasshopper, because I've showed you how we can plug them in. And it's fairly comprehensive, and you'll probably just pick it up because many people are technology natives these days. You're pretty savvy when it comes to learning things. But I just wanted to just quickly go through this anyway, just to show you how the wires work. But the way the wires work is we can click a wire from one side and we can drag it into another side, and it will take this data here and put it into this data here. If I wanted to deselect that or get rid of the wire, what I can do is I can hold control while I'm doing the same thing, and it will then erase the wire. So it will get rid of it. So I can put a wire in. If I hit control and pull that across, it will then detach the wire and no longer be there. Okay. Also, another way to disconnect is we can right click on here and we can select disconnect just here, and then we can choose what we would like to disconnect, and then as I hover over that, it will highlight it in red. I can choose disconnect and I can disconnect it that way as well. So there are two different ways that you can disconnect. If I want to put multiple wires into one input curve, so let's say that I have two different curves in my Rhino interface, right? And I've got curve one. I right click on here, I set one curve. Then I right click on this one, I set one curve. I have two different curves. Let's say I want to bring them both into this divide curve. What I can do is, as I do this, I'm just going to detach both of them. So I'm going to put the first one in, and if I try to put the second one in, it detaches the first one because it doesn't understand that I'm putting more data in. So it will get rid of the first set of data and it's only receiving one set of data. However, if I hold shift while I do it, it will allow me to put multiple data sets into there. But I need to hold shift while I'm doing that. So I just select the left hand side, I hold shift, and I drag to the right hand side, and now I can put multiple levels of data into this component by holding shift. Let me just explain to you the fancy wires. And up here on my display, I can do draw full names, but I can also above that do draw fancy wires. And I can turn that on and off. And if I turn it on for a second, it will allow me and display fancy wires. And let me tell you what these are. So if it's orange, if the wire turns orange, that means that there is no data that's being passed. If it's just a single dark gray, it means there's a single amount of data being passed. If it's a hollowed out wire with two gray lines at either side, it means there's multiple items being passed through there. And if it's got like a dashed line as well, it means there's multiple nested lists being passed through. Okay? And so it'll become more apparent as we go through. But if I turn off draw fancy wires, then they'll just all remain the same and I won't be able to see those. If I put my draw fancy wires back on, then I'll be able to see and differentiate the difference between those wires. Okay? Right. So that's some of the theoretical side of Grasshopper. We also can do math components in Grasshopper where we can do some mathematical parameters, and I'll show you those in a moment, how these work. But before we do that, I want us to, let's just start actually creating something, and we'll just create our first parametric tower or whatever it is that you would like. I'm just going to unpin that. Is it here? It's high. I don't know how I move this guy. Yeah, I don't know either. I don't want to stop sharing. Strange. I'll just move it down a little bit, but there we go. So what I'm going to do now is we'll just start a new file and we're going to create our first parametric tower. We'll create a parametric tower together. So what we're going to do right now, in order to do this, is we're going to create an ellipse as our starting point. So I'm just going to right click on here and I'm going to type ellipse. And what I would like you to do is I would like to follow along with this as we do it. If you already have the ellipse there that you already created, great, because I'm going to show you how we can then work with this. I'm going to just then double click again and type 100, and I'm going to make my ellipse 100 meters wide. I'm going to Control C and Control V and copy that, and I'm going to make it again 100 meters. And now I have this tower base point or base curve that I can use as the starting point of my tower. Okay? So now let's say that I want to then create the next segment of the tower, and I want to then bring up another curve from this curve, but I want that to have different parameters. So what I would need to do is what I'm going to do is just double click on my interface, on my Grasshopper interface, and I'm going to type move. And I want to move this curve upwards. Okay. So I need to input my ellipse curve into the geometry. So I'm outputting my ellipse, but I'm inputting it into my geometry. Okay. By default, it's going to give it a motion in the z-axis of 10. But if I want to be able to control that with a parameter, again, I need to put a vector in there. So if you remember before, I went to vectors, vector, and I'm going to use a unit Z, and I'm going to bring that into here. Or I can double click on my interface and I can type unit Z, and I can drag and drop it in that way as well. So I'm going to put that into my motion. In order for me to then control that height, I'm just going to double click and I'm going to type 100, and I'm going to bring a number slider in. That's going to allow me to make a 100 meter high tower, let's say, or the next point in my tower can be a maximum of 100 meters. And I can just move that to to show you how that's working. Okay, so the next thing that I want to do is I want to now create another ellipse, but this time I want it to be higher up again. And instead of this being referenced, so what's happening right now is with this ellipse, my first one, if I change my first one, it's going to change my second one. But let's imagine that I don't want that to happen. I want it to be able to control that separately. What I would need to do, rather than doing move, because it's just referencing my original data, what I would need to do is just copy this ellipse again, Control C, Control V. Okay, and I want to then bring this new ellipse into my geometry and move. And what ends up happening is I have the original ellipse, but then I have this new ellipse that I've created. But this time, this one is adjustable separately. Yeah? You see that it's adjustable separately. But you can see I have my original ellipse. But if I don't want to see that, what I can do is I can just right click on here, and I can turn the preview off. So I'm going to turn my original ellipse off and just keep my new output ellipse, which is just here. So now I have two ellipses, ellipse 1 and ellipse 2, that I can then use. Okay, let's say I want to do a third ellipse for the top of the tower. I just follow the same process. I can just copy and paste all of this time, Control C, Control V, and now I have a third ellipse, which is going to be my highest ellipse, but this time I want it to be much higher. So I want to just double click on here, and I'm going to change this to 200, let's say, and we'll do a super high tower, and then I can move that. And now this ellipse is also controllable, and I can adapt it and adjust it. My middle one's controllable. Okay, so I've got my first ellipse, I've got my second ellipse, and then the moved version, and then my third ellipse and the moved version. And I end up with these three curves that are being output. If I have this curve here, this curve here, this curve here, I have them on the same level of hierarchy, as in I wanted them to be together. So what I can do here is I can either pull this one across so it's like aligned with those guys, or what I can do is I can just use another parameter, which in this instance will be like a curve parameter. So if I just click curve there, I can just bring a curve parameter here, and then I can reference this into here, and now that's called my ellipse. But what I can then do is I can go onto this, and if I right click on it, I can change the name of it from curve, and I can say that this is my base curve, for example. So I can just hover over that, right click, and then I can just change the name of it here. So I say that's my base curve. So I know that that is now my base curve. Yeah. And I can do the same with these guys as well. So if I want to clean my geometry up and just make sure that I'm just then referencing certain parts of the geometry, I could do the same here. I could bring this curve here, and then I could go here, right click on it, and say, I'm going to say this is my mid curve. This is my middle curve. And I could do the same again. I can just drag a curve onto here, and I can say that this is my top curve. Top curve. Okay? So all I've done is just dragged a curve component, and now I'm referencing that geometry. And now I have these three guys here. That is my base, mid, and top. Okay? Does everybody need a moment to do that? Has anyone not been able to do that and needs a bit of time? Yeah? So, have you managed to create the script so far? It's just the curves here that you're just waiting to put on there. So if we go to curve just up here, or we can double click and type curve, and we're going to reference that curve. And this is just a way for us to just tidy up our Grasshopper script as we go along, so we know what we're referencing. Another way that I can do that is if I hover over everything, I can right click and I can group it together as well. So let's say I want to group all of that. Now that's all grouped. So I could group my top, middle, and bottom curve, for example. And I can organize it here. And what I could do here with my group, I can right click on that. I can give that a name. I can say top, for example, and then that will give that group a name. So I just select everything. I right click on it and I click group. And then if I just right click on my group, what I can do is I can change the name, middle, for example. I think that I did that wrong because that's the bottom. Bottom, curve, for example. And then you can name your groups as well. And then this is the top curve. Okay? So I'm showing you how we can just like organize our script. So now I have these three curves that have been output at the end. So let's say I want to loft those curves to create a tower. Okay? What I can do is I can double click here and I can either type loft just there, or I can go up here and I can go to surface, and again in freeform I can see also that there's the loft, and I can just drag and drop that in and I can loft these curves. But what I want to do is I need to make sure that I add them in the order that I want it to loft. It's really important that we do it in the right order. If we don't do it in the right order, it will loft in weird ways and we don't want that to happen. So in order to loft this in the correct way, I'm going to start with the base curve and I'm going to drag it into my curves. And if you remember, if we hold shift, I'll be able to add the next lot of curves, which is great. And then if I hold shift again and add my third curve, I can now create a loft of my tower. And as I adjust these guys here, you'll see that it will update and change my tower. If I want it to be smaller, for example, if I think the footprint's too big, I can just decrease it here. I can decrease it here, and I can decrease it here. And it can do the same again at the top. I can decrease it here and decrease it here. And then I've created this tower. Okay? Now let's say that I want it to be a twisted tower. What I can do is I can take these curves before they move and I can output between here and here a rotation. So I can start to then rotate it, and then I can bring that rotated curve into my loft, and then I can add rotation as well to my curves. So in order to do that, let's just undo our loft by just holding control, and we can undo our wires. And one of the useful tips that I've got for you to give yourself a little bit more space, if you hold Alt whilst you left click, you can just drag this across and we can give ourselves a little bit more space within our Grasshopper interface if we want to start adding more geometry or more nodes into that area. So I want to, in this instance, add a rotate node. So what I'm going to do is I'm just going to double click. I'm going to type rotate. I'm going to rotate an object on a plane. And I'm going to input this guy into here. And you'll see that it starts to rotate. Now I'm going to put a number slider on here to 360. Why am I doing 360? Does anybody know? For the angle. So a full circle goes from 0 to 360 degrees. Now you'll see that there's a slight problem when I do this angle and I start to then adjust it. It's like going crazy because right now it's not using degrees, it's using radians. And the way that radians work is slightly different than degrees. So what I need to do is I either need to put a function between here that says degrees, or I can right click on here and change it here to degrees. And now you should see that it works. Okay? If I want to make sure that my maximum is 360, I can go here. I'm going to type 360, compress, enter, and now that my maximum will be 360. And then you see that as I rotate that, it rotates it around. So now I have a new curve, a rotated curve, but I want to now input that to my mid curve here. So I'm going to input that into my mid curve here. And I'm going to, again, right click on this one and turn the preview off because it's actually this one that I want. So now I've created a rotated curve. If I want to follow the same logic again, all I need to do is just copy and paste this down and just do the same again with this curve at the top and then input it into my top curve. I can just right click on this one and turn my preview off. And again, I can now adjust this curve and adjust its rotation. Okay? Has everyone been able to do that? You okay? It says what, sorry? So if you just have a look at my screen here, if you have the loft here, have you got your move? And then we're going to add a rotate. And we're going to put our geometry from the move into our geometry into rotate. Yep. And then we're going to put a number slider into angle. And then we're going to right click on it and change it to degrees. And then it should update to degrees. And then we're going to output this to our curve. And once you've done that, I'll come over to you in a second. I'll just want to input these into the loft. And you'll see that these are now being input into my loft as like a twisted tower shape. So just have a little play around with your parameters on there whilst I just come around and help anyone that's struggling with that. And you can just start to adjust your parameters. You can adjust the size, you can adjust the rotation, and this is your first parametric tower. So all I did with that is I just turned them off whenever you need it. So you guys here, you right here, turn the preview on. When you turn it on, we velocity. Yeah. Yeah. So for this, Turntable, lovely. So it's just the way that you lock with these curves right now. Which I get the same. So let's just clean it clearly all over. The reason I have these is you get this through these later. And I want them to, I want it to be in the here so that we hold each other. They don't get that maybe. So is everyone be able to do that? Okay, the next thing that we're going to do is we're going to put slabs on this. So in order to change, this is for everybody, in order to turn off. So as I've been going around, there's a couple of ways that we can display our data. So if we keep everything on preview, what you're going to see is I end up with all of my different curves. All I need to do to turn off my earlier curves that I no longer need to see, because I'm only using them as reference geometry, is I just right click on it and turn the preview off. And then I right click on it, I turn the preview off. I right click on it, I turn the preview off. If I select them all at the same time, I can right click above all of them and turn the preview off of all of them. And I can do the same here. I'm just going to select all those guys, right click, preview off, and I've turned the preview off for all of these. Okay? Yes? So all you would need to do in order to do that is change the plane, which is just here. So if you look here, it's getting world coordinates X, Y. So you would just need to change the orientation of that plane. And there's different ways that you could do that. Right now it's saying rotation plane X, Y. We will just need to change that rotation plane to X, Z, for example, and then it will rotate in the X, Z. So in order to do that, you would need to use some of the, let's just see here on the vectors, you see where it says plane. These are the different types of plane. And we've got XY, YZ, XZ. So for example, XZ, if I just plug that into there, you're going to see it's doing it in the XZ instead of the XY. So that's how you would do that. Another question that I saw is, why are we putting these guys at the end? Why are we putting this curve here at the end? Why am I creating a new curve to just input here? Can anybody answer that question? Just cleaner. So it's just cleaner. It's just to clean up my model, to make it nice and clean as I'm going through. Otherwise, I'll end up with just spaghetti everywhere, and I'll get really confused as to where things are. So all I'm doing is just creating a new parameter that's going to input that data And now I've got that data nice and clean. If I'm not bothered about any of this data anymore, I don't want to make it parametric anymore, I could even go as far as right-clicking on here, and I can actually internalize the data. So let me see where it says internalize data. If I click internalize data, it will take all the data before it. It'll internalize it into that one component. And now I'm no longer parametrically able to control the model. It's just inputting that data into that curve. So if I'm like, yeah, I'm happy with it, I don't want to adjust it anymore, you can internalize the data as well by doing that. Okay? So the next step that we're going to follow is I would like you to now, let's say we want to create some slabs in between here in our tower. Okay? In order for us to be able to do that, what I need to do is I need to get some curves that go all the way up. And then I'll be able to use those curves to then extrude it up and create some floor slabs, for example. So what I'm going to do to be able to do that is use a command called contour. So what I'm going to do, I'm just going to adjust this a little bit so I get a nicer looking piece of geometry. Because I don't really like how it's going right now. So I'm just going to get a nicer sort of like twisted tower on my screen. And I'm going to use the contour command. So I'm going to just double click and type contour. And the contour that we want to use is this one here, which is create a set of B-rep or mesh contours. With the one with like an orange plane next to it. That's the one that I'm going to use. And what it's going to ask me for is the shape, the plane, which will default to XY, which is fine, the number of offsets, and then the distances that I want to offset. Okay? So if I wanted to contour this, I can input the shape here, but it's not outputting anything yet because I've not specified the offset or the distances. So in order to specify the offsets or distances, what I need to do is create a series of offsets that I want to create on here and then specify what the distance is that I want those to be. So I can use a series of numbers in order to specify that. So if I just double click and type series, I can create a series of numbers. And the way that this series works, it's got a start point, a step distance, and then a count. Or let's think about our tower. What could this be? Our start point could be the base of the building. Our step could be the floor slab heights. And our count could be number of floors. So we could even change that as well if we want to. So if I wanted to change that, I can right click on there and say the base of the building, for example. The step could be the floor slab heights, for example. And the count could be number of floors. Okay? And so we can also change it on there. If you don't want to change it and you want to keep it as it is, just so you remember what the data is, you can always just keep it as it was, which is fine. I'm just showing you here how you can change that. So for the base, we want that to be 0. So I'm just going to put a number slider in, 0. I'll just put that into there for the base. For the slab heights, let's think about what height that we want our slabs to be. Typically within like a tower, the floor slab heights might be like something like 4.5 meters to 6 meters. So if we did like 4.5, I think that's probably going to be okay. So that's the slab heights, right? And then the number of floors. Well, right now we need to calculate how high our tower is. So if I wanted to calculate how high our tower is right now, what I need to do is I need to take my base curve and my top curve, which are these numbers here for the unit Z. And then I need to know and add these two together to then get my final height. So for example, if I just double click and use an addition, To do that, I can just click addition, and then I can input these two parameters. So 70 meters is my first height, if you remember, and then 200 meters is my second height, if you remember. And then that's going to then give me the overall height. So I'm just going to put that slab in there, and yeah, I'll answer your question. So now I know that the height of my building is 270. Oh, sorry. When we were creating the ellipses, we don't need this one. So we know the building height is actually just 200. Yeah. So we don't need that. So we don't need to add this together. So I'm going to get rid of that guy. So we know actually the height of our building is this one here. So I didn't need to add them together. But if you were offsetting that second curve from the mid curve, that's when you would need to do the addition. Because we were doing it from the base, we know that the height of our building is 200. So with a little bit of mathematics, we can work out the number of floor slabs that we need. So what we need to do is if I just double click on here and I do division, for example, and then I go 200, which is my height of my floor slabs, and I divide it by then the slab height, technically speaking, it will then give me the number of floors that I would need to have. Does that make sense to everybody? So I'm taking my building height, I'm dividing it by the number of floors. In order to make it a little bit easier, let's just do it like 4. So we got 50 floors. So if I do 4 meters, then I know I've got 50 floors on there. Okay? So the number of floors, I can actually even input this guy into there. And then that'll give me my number of floors. So in order to pan around, it's just similar to your Rhino interface. If you just right click with your mouse, you can pan. You can zoom in here. You can right click and pan. And then if you look down here, it also gives you some, it shows you your compass, find your way home. So it shows you on here where your parameters are in the model. So it shows you up here, it's kind of like a navigation waypoint. It shows you that it's over there if you zoom out too far. But does that answer your question? Yeah. So just scroll with your middle mouse wheel or right click to pan. Okay, now that we have that, we can just input this into our offsets, and we have now our floor slabs perfectly created. Did that make sense to everybody? You look confused. Do you want me to clarify anything, or is there anything? Okay. So do you want me to do it again? So I created just a series, and I changed the base point, the slab heights, and then the number of floors. Okay. For my base point, I did it at 0. For the slab heights, I did it at 4 meters. But in order for me to calculate the number of floors, what I can do is I can take my building height, which I know is this one here, and I can divide it by the number, by the slab height, and then that'll give me my number of floors. And I can just I can use like a division if I wanted to do that, and I can go and take the height of the building and put that into the first part of the division, and then I can take the slab height and put that into the second part of the division, and then that will give me my number of floors. And I can then input that into the number of floors. Or if I'm just pretty confident with it, I can just put any number in there. I can say 50, and I can use a number slider for the number of floors as well. And I can input that into there. Okay, so now that we have this contour, what we want to do now is we want to extrude it upwards to create a slab. And in order to do that, what I'm going to do is I'm going to use an extrude command. And I'm going to bring that in, and I'm going to plug my contours into the base, and it asks me for a direction. And we've done this a few times before. So in order to specify our direction, we need to use unit Z. So I'm going to double click and type unit Z and just drag that in. I can bring that into there, and then that will start to extrude it. but you'll see that what's happening right now is it's only extruding the outside of my object. So there's a step that we need to do between that in order to stop that from happening. Because what's happening right now is just taking that curve and it's extruding it up. We want it to extrude as a slab. So there's a step that I would need to do before that extrusion in order to extrude it as a whole surface. So the way that I'm going to do that, remember before I said you hold Alt and you can just drag across to give yourself some space. I'm going to turn this into a boundary curve. So I'm going to take my curves and create it into boundary surface, sorry. So I'm going to take my curves and create a boundary surface. So if you double click on here and type boundary surfaces and just drag that in, I'm going to take my contours and I'm going to make a surface out of those. And then I'm going to take my surfaces and extrude those up instead. And now we should end up with some slabs. If you want to check, just turn off your loft and you should see some slabs that look something like that. Okay? If anyone has any questions, please don't hesitate to ask as well, and I'll happily answer them. You could use either or, and again, what we can do is we can just look here. If we hover over here and just click on help, this tells us what a boundary surface is. It just creates a planar surface from a collection of boundary edges. So it does the same thing, or you can just create a surface. So you just use surface. Sorry, up here. And which one did you use? Just surface. Just type surface like this. Or did you use a plane surface? Just a surface there. So what should happen here is if I take my contours, if I just right click on that, and then I just input this guy into here. Yeah, it could do the same thing. So it allowed you to create the surface just from the edges. But typically what I like to do instead of this, because this is a parameter that's holding data, I like to use something that is then giving me information, because this is a parameter that's just holding data. It doesn't tell me the input and the output. It's just telling me that this is a surface. Whereas if I use the boundary surfaces, it's telling me the edges that I'm receiving and then the surfaces that I'm outputting. So, but it's up to you. You can use either or, but I typically like to use the parameters that give me more information. Because when you're working in firms, in Grasshopper, you need to hand this off to somebody else. They're going to need to interpret what you've done. And which is why it's really important that we clean up our model, make it super clean, and then we organize it in a way that's readable for other people when we come to do it. They come to use it in the future. Go ahead. Yeah, so what you'll see happen, because of the way that our surfaces work, some of our surfaces will be outside of our slightly overlap just because we're using a curved surface. So there's a way that we could try to tackle that without going into too much complex detail. What we can do is, if we were creating a facade, we can just offset this surface now ever so slightly, so we give ourselves a little bit of extra space. If you wanted to use a cut through, we could try and cut through the extrusion. So we could say, okay, I want to do a Boolean difference. And then get rid of the outside part. But just because it's an introductory session, what I'll do is I'll just show you the very basics, and those kinds of things is things that we can do further down the line. But yeah, if you wanted to like cut through it, you could do. But for now, I'm just going to do it quite simple, and I'll just offset the surface for now, just to create a facade on it, let's say. Okay. So has everyone been able to create this? Does anybody need any help? No? Everyone's good? Guys over there, were you able to create? Yes? Perfect. Girls, are you okay? Were you able to do that? Amazing. That's great. So as has been rightly pointed out, we now have like this data or this geometry that then gives us a slightly intersecting floor slab with our facade. If we want to resolve that, we can actually just offset our facade. And the way that we would do that is if I just clean this up a little bit, I'm just going to clean this guy up. So what I could do here now that I have my slabs, I can bring these here. And again, I could either group them, you know, if I wanted to clean my model up, I could group them. And then I could say that this is my floor slabs. So now I've created some floor slabs. And now, if I want to create a facade on here, I'm going to take my lofted surface, which is just this guy here, and I'm going to just bring this out to a new parameter. So I've got my surfaces parameters just up here. I'm just going to bring it out as a surface, which is this one here, and I'm just going to drag that in, and then I can reference that geometry, and now I have a surface referenced. So this is now my facade, and I could even just right click on that and rename it to my facade. And now we're going to start working into this facade. So first things first, let's just offset it a little bit so we can just bring it off our floor slab. And the way we can do that is we can just type offset, and that will allow us to offset our surface. Now remember, there's input data and then output data, and then it forms our function in between. So the input data that we need is our surface. We need a distance, and it says retrim. We don't need to worry about the retrim just right now. We just need to worry about our distance and our surface. So for the distance, I'm just going to put a number slider on there before I run this command. And let's say I want to just offset it by like 2 meters, let's say. If I do 1, the way that Grasshopper works with number sliders, if I type 1, my upper limit will be 1. If I do 8, my upper limit will be 10. If I do anything above 50, my upper limit will be 100, and it just like jumps up in increments. So if I want it to be bigger than 1, I need to like do 2, and then my upper limit will be 10. And that's just a little tip. So if I do 2, then I can go down to 1, but I can also increase. I can do that as the distance, and then I can input my facade as the offset. But what you'll see happening right now is as it's offsetting it inwards. If I wanted to offset it to the outside, I could make this a negative number. So I probably need to make this a negative number for me to be able to do that. So I double click on here. And then what I can do here is I can make the minimum to, if I just double click, minus 10, for example. Click the little green tick and click OK. And now I can bring it to the outside rather than just the inside. If I wanted to be more specific with this number as well, I could do different decimal places on here, and I could even just say minus 1 and an upper limit of 1 if I want it to be 1 meter, and then it'll just offset it like, let's say that's 873 millimeters that it's offsetting it. And so I can also be more specific with my numbers as well if I want to be. But let's just offset it to an amount that just sort of starts to cover most of my facade where it's extruding through. And in my instance, is like 0.5 probably is about enough. So that should be okay. If I go back to integer numbers, that makes it whole numbers. And that'll be go from 1. But if I want to have more control, I can just do it there. And I can just do it there. And if I want to change the number of decimal points, I can also adjust that here. So it's 0.1. I can do it at 0.5, for example. So now I can use this as my new facade that has been offset. So what I'm going to do is I'm going to use Lunchbox now. And these are different, there's different paneling tools that we can use on a facade from Lunchbox. So we have these different panels here that we could put on. We could use a skewed quads. So I could put this here. And the U divisions and X divisions come in by default. So let me just turn off these surfaces just so you can see. I'll turn my preview off. And then I'm just going to turn off my slabs just for a moment, just so I can show you this. So what's happened now is I've taken that surface and I've divided it into different panels using the Lunchbox component. So I've got skewed quads right now, and I've got 10 in the U division and 10 in the X division. If I want to make more divisions, all I need to do is just bring a number slider in. Let's say it's 50. And I'm just going to copy that twice. And I'm just going to bring that into the U. And you'll see that as I increase that number to 50, it's increased it there. I can also increase the number of V. And what's happening now is it's taking this and it's dividing it 50 times in the U and then 31 times in the V. Okay? So now I've created this facade. I can increase it if I want them to be higher. So let's say I want it to be 25 so that there's 2 quads for every 2 floors. I could do that. Or I can, divide the number of divisions. But the more that I divide them, the more fidelity that I'm going to lose here. Because it's like they're quad panels, they're straight panels. And so it doesn't follow the curvature of the surface. It does these as like quad panels, straight edges. So it's going to start to become jagged as I increase that. Which actually could be quite cool because I might say, okay, I want it to actually I want my tower to be like this. Kind of like SOM, Norman Foster style Gherkin. I'd say this is my structure. I could do that. Or if I want it like more as like a facade system, I can then increase it and just create a little bit more fidelity within my model. So this is like a little bit like the Gherkin. I could also use other quad panels. So I'm just going to delete that for a second. And I could use like triangle diamond panels. And I can increase these. And now these are like triangulated panels. So there's different panels that I can create. Now, if I want to be able to visually see this in my interface, in my Rhino interface, I can use a custom preview. So I can double click on here and type custom preview. And what this will do is it will just give me a custom preview for these panels of what they look like in my Rhino interface. So I'm just using a custom preview. If you want to change the color, you can do a color swatch just here, and we can bring that in, and you can just change the color to whatever color you want again. So that's how we can do a custom preview. If I want to do a custom preview of my tri-panels as well, which is these triangular panels that are left over, I can do that as well. So you'll see that this seam doesn't directly line up, and that's because I'm using an odd number in this direction. If I make it an even number, you'll see they'll line up perfectly. So now I have these facade panels. Is everyone okay with that? So I use a Lunchbox. I just plugged it into my surface and just output there. Go ahead. These ones. So if you just select all of them and just right click above and just do preview off, it will just turn off the preview. Or if you want it on a singular node, you can just right click on that node and do preview off. So we can just toggle the preview on and off by just right clicking on it, and we can turn the preview on and the preview off. Okay? Does that answer your question? Perfect. Okay. So let's say, for example, I want to do something interesting with this building, and I want to do it a little bit like, let's see, lava. And let's say that I want to do something with this facade that does different openings and closings on the facade. Let me just try and find, like something like this, like a stadium type thing. Or there's an even better example. Um, so you see these types of facades here, where we've got these triangles that open and close in different sizes. Actually, this is an even better example. So we've got Tom Wiscombe did a really cool project where essentially it's showing us this type of Grasshopper script and how we can create this type of Grasshopper script. I'll go to menu. I'll go to work. And this Tom Wiscombe has done some really amazing computational design. And one of his sort of earlier projects, let's say most famed projects, is this one here, the Beijing National Hotel. And we can create this kind of facade on our tower using Grasshopper. And we can use Lunchbox to do that. But what we need to be able to do is create a certain logic for us to be able to do that. And the way that we can do that logic is using what we call attractors. So essentially we need to create a logic that says, okay, according to an input that I give, I want these to open or close according to a point in space. And the distance of these parameters to that point in space. So as they get closer to the point, they'll open up. As they're further away from the point, they'll close. That's like parametric facade. This is a logic that we use called attractors. And I wanted to just show you how attractors work, because this is a really good logic for Grasshopper. So if I wanted to create a logic for this, for example, what I want to be able to do is, if I just go here, I think I've got an attractor definition here, and I just wanted to show you how this works just really quickly, how the attractor works. So I want you to imagine just for a second that I have here a grid. In fact, let's do it together. I want you to just do it together. Just save your file, by the way, because we're going to come back to it in a moment. Just save it. I'm going to show you attractor definition. Go ahead. I'll come and check it in a second. And the beautiful thing about Grasshopper, the files are really small because it's only containing data and information. So they're smaller than Rhino files. So what I can do is just save that file. And I'm going to take you through this just a couple of steps at a time, is how an attractor works. And then we're going to apply that logic to our facade. Okay? But yeah, all you need to do is just save your file and just create a new document. And what will happen is up here, you'll see it'll keep all of your other documents. Oops, don't want to get rid of that. It'll keep all of your other documents open here, and you can just open them and close them as you need. But the new one that you create will just be in here. And we're just going to follow this attractor definition. Let me just come and answer any questions. Also, if you try hands, you can bring that in. Tension. And then you damage. The tripanels work differently because the tripanels are created from the outside edge. It's not an entire diamond or two part diamond and the triangles that are on the outside edge. Yeah. Right. So yeah, in the tripanels, I would build. So if you want to hide this, just right click on it. Humidity. Yeah, and it's sort of preview off. And then you should stay here. Okay, is everyone okay? Following along? So I just want to teach you the logic of attractor points first, and then I'll show you how we apply it to our building facade. So the way that we're going to do this is we can create a grid. I just want you to create a square grid, just very easily. It could be a square grid, it doesn't really matter. Just double click and type square. And it's this one here. We're going to create a 2D grid of squares. And you can change the size and the extent Y and the extent X, sorry. And just put like up to 20 points in there for each. And then for the size, this is just going to specify the size of that. So we'll do the size as 1. We'll do extent X like 20 and extent Y 15. That'll be nice and easy. Okay, after we've done that, so what's happening here is this tree is getting flattened. So let me just explain to you what's happening here. So the way that data works in Grasshopper, what's happening right now with our grid, if I just plug it into here, you can see that 3 numbers are being output all the time. So we have 0, then we have 1, 2, 3, 4, 5, 6, 7, 8, and then all the way to 15. And then our next row starts, and then it's like 1, 1, 1, 1, 1, and it's going to give us every single column. So if I show you what that looks like, if I just show you on a points list, so we can put a point list on here, which will tell us the order that our points are going. And if I just specify the size of this here, let me just, oh, sorry, I'm doing list, I need points. So I just need to decrease the size of this. And what this is doing now, it's just showing me the order that my points are going. So the points are just going in columns like this. So the way that our points are working is in columns. So we've got 0 to 15, and then it starts the next one, 0 to 15, then starts the next one, 0 to 15. If I was to take this data now, it's being very rigidly organized. If I was to flatten that data, what I'm essentially doing is going, take everything out of the list, and let's just put it in one long list. So rather than having lots of lists of 15, if I was to flatten it, I go from 0 to the end number all the way through, ignoring my columns. So I'm no longer going 0 to 15, it's like 0 to 15, then I go to 16, 17, 18, 19, 20. And let me show you what that looks like. So if I show you the flattened version in this points list here, I'll show you the flattened version. I'll just turn that off just so you can see. I need to decrease the size of this, so I'm going to do it as 0.25 because it's just too big. So this is my flattened list, and what it's doing is starting at 0, it's doing to 15, and then it's doing 16, 17, 18, all the way down to my end number, which is 335. So that's how flattening works. And we often do that in Grasshopper when we want to take lots of data and we want to create just one list of data. The opposite of that is grafting. So if I had a list of 335 points and I wanted them to be rows of 15. I would graft it, and then it'll allow me to organize it into rows. If I want to see this visually, let me just show you this very quickly. There's a tool that I can use to be able to see this visually, which is in the params and utilities. If I just show you this, this is a tree. If I just put these points into here, it'll show me my tree. If I double click on that, it shows me like how my data is being organized right now. So it's showing me that I have lots of these rows that are happening before I've flattened it. Watch what happens when I plug it in for after I've flattened it. So after I've flattened it, it takes that into just one list. Okay? We're not going to go into data structures and data management into a lot of detail today because this is just an introduction session, but I'm just giving you a quick overview of data and how data is organized. So if we flatten data, it takes a list and flattens it. If we graft it, it then starts to organize it. So that's the flattened list, just one list now. And if I just double click on that, it shows me that there's just one branch with 336. If I go the unflattened and put that in, it tells me that there's 21 branches, all with 16. Now, many of you might look at it and go, actually, no, there's only 15. One thing to always note in Grasshopper is 0 is always counted as a number. So our first number in our list is always 0. So although it goes up to 15, it's also including 0, which means we have 16 numbers because we always include 0 in our number count. So that's just a quick breakdown and understanding of that. So what's happening then is the list is then getting flattened, and then I have these circles that are coming out of that list. So what I want you to do is I want you to just create that exactly as you see it here on the screen. So we're going to create a square grid. We're going to do a flattened tree because we're going to flatten it. And then we're going to do a circle with a radius of, let's say, 0.4. Or you can do it 0.5. But 0.4 should be fine. And our grid is 1, set to 1. Okay, has everyone been able to do that? So after we've done that, what we need to do is we need to then create a distance, which is going to specify our radius. Okay, so between these guys here, if I just move this guy out a little bit, let's say instead of having a distance here that I'm specifying with a number slider, let's say that we're setting a distance according to a point. Okay, so what I could do is, in order to do that, is I would bring in a distance, which is just here, vector distance. Do you see that? And it will compute a distance for me. Or I can double click on my screen, I can type distance. I can bring distance into here. And let's say that I want to specify a point here in space by creating just a single point. So I'm just going to create a single point in here in my Rhino interface. And that's going to be my point. And I'm just going to double click and type point. And I'm going to reference that point that I've just created. Okay, so I'll wait for everyone to catch up to that point. So we've created a distance. I have a point. And this is going to be my attractor point. This is the point that I'm going to use that specifies the size of these circles. So as it gets closer to the point, they're going to be a certain size. As it gets further away from the point, they're going to be a certain size. Okay? So in order to reference that point, I need to right click on it and do set one point and then select my point. Has everyone been able to do that? You couldn't flatten it. So all you need to do is type flatten tree in here, flatten tree, and you're going to bring this component here, and you're going to take your points and you're going to put them into tree, and then you're going to take your tree and then put it into your circle plane. You've done that? That's fine. If you've done that, then that should work. So don't worry too much now. Like, as long as you're following what's on here, that should be fine. So with regards to the circle size, I'm going to now put that into point A. My flattened list into point A, and I'm going to put my other point into point B. So I've got my flattened tree. And why am I flattening this list? The reason that I'm flattening this list is because I want these points to reference to this point. But if I had them in lists, all that would happen is they would just get bigger as they get further away. So all of the circles would be the same size all the way down, and they'll just get bigger as they go further away. Does that make sense? But by flattening the whole list, they all behave individually, and every single circle will have a different size. Does that make sense to everybody? Yeah. So every single circle we want to have a different size. And the way that we want that circle to have a different size is by the distance that it is. So what we're going to do right now is you're going to see it's going to get crazy. Our model's going to get crazy because what we're doing right now is we're taking point A and the center of it, and we're going to take the circles in the center of those circles, and then whatever distance they are from our attractor point, we're going to make the radius of that circle that big. So they're going to look really huge. So if I plug that into my radius here, you'll see that my circles start to look really huge. Does everybody understand what's happening here? Does anybody not understand what's happening here? And don't worry, I don't mind explaining it for everyone's benefit. Is there anybody that doesn't understand what's happening here and why these circles are so big? Don't be afraid. Don't be afraid, because I'd rather you understand it than just sit there quiet and go, yeah, I understand. I'd rather you say, no, I don't understand, and let me explain it. Do you want to explain it? Exactly. So, you get it. Yeah. So, what's happening right now is I'm taking my flattened tree, which is my list of points, these circles here, and what I'm doing is I'm saying, okay, I'm going to get a distance of the center of each of these points to my attractor point, the point that I created over here. Okay? And then I want the size of the radius of those circles to be that distance. So if the distance is further away, the circle that is over here is going to have the biggest radius. Because it's the furthest away from my original point. Whereas the circles that are closest to it are going to have the smallest radius. Because what I'm doing is I'm saying, whatever distance they are, make that the radius. Does that clarify? Yeah? Perfect. So, with that being said, what I need to do now is go, okay, I now need to change these numbers. And in order to change these numbers, I need to understand a certain mathematical logic. By the way, watch what happens when I move this. Everything changes in real time. Okay? So I can create really interesting patterns by doing things like this. But it's not ideal because I can't really interpret what's happening. So what I need to do instead is I need to create a certain logic where I remap the numbers and create a new domain. And the way that I'll do that is I need to use bounds, I need to use remap numbers, and I need to use construct domain, and I'll show you how that works. So let's just let's create bounds first of all. And what that's going to give me is my minimum and maximum bounds of this domain. And I'm going to plug that into my distance here. And then if I just put a parameter in here, you'll see it gives me my minimum number and my maximum number. So when I'm creating bounds, I'm creating my minimum number and my maximum number. And that's giving me my bounds. It's saying this is the absolute closest point, this is the furthest point away. And that's how bounds works. Okay? Yeah, exactly. So that helps us to understand what our range is. Okay? This all gets very mathematical. But if you understand some of those early mathematical lessons that you did at school, like about range and about median and about like we've got like domains. I don't know if you ever did domains, but we're going to talk about that in a second. If you remember some of those early mathematical things that you did, this is when they're going to come in really handy. The things that you said you're never going to use again in your life, you're about to use them. So it's really important that you understand them. So our bounds, exactly, it gives us our minimum and maximum number. But also, we also need to then construct a domain. Now, let me explain to you what a construct a domain does and what it means. Or does anyone want to hazard a guess or show me, really impress me and say, this is what construct a domain is? Go ahead.
Create that domain into the language and you really want to define for that domain. Like you want to have a starting point and based on the values that you want, that it works proportionally to the price that you have.
Exactly. Yeah, and I'll explain that to you with a diagram. There's actually a really nice diagram on this lesson. Um, if I, it's not on this one, but what essentially it's doing is it's taking these numbers that I've created, and it's going to allow me to go from 0 to 1. So rather than me having to worry that it's from 0.5 to 22, it's going to take those numbers and it's going to reconstruct them from 0 to 1. So the number 11 will be 0.5, for example, in my note. If it was from 0 to 22, the number 11 will be 0.5. So it's just restructuring that number, those numbers from 0 to 1, and then giving it a proportional place within that. Now it's really hard for me to work out what 0.538598 and 22.6744 would be if I remapped it from 0 to 1. I just couldn't tell you that off the top of my head. But by using a construct domain, it'll do that for us, and it will just remap it from 0 to 1. Does that make sense to everybody? Okay, so what we need to do then to construct the domain is we need to follow the logic of remapping the numbers. So in order to remap the numbers, we need to type remap numbers. And we're going to remap these numbers here. And the logic that we need to follow is we need to put our bounds in the middle, our domain as the target, and our original numbers as the value. So we need to put our distance here as the value. We need to put our bounds as the source, and then we need to put our constructed domain as the target. Okay, but before you do that, we just need to add two numbers, a start domain and an end domain, and it needs to be any number from 0 to 1. So I'm going to do 0.025 and 0.531, for example, as those. But essentially, this just goes all the way up to 1 with 3 decimal places. And again, it goes from 0 to 1. And we can do our start and our end domain somewhere around about there. Okay, so in order to create a number slider that gives us 3 decimal places, I'm just going to type 1.000, press enter, and it will give us a number from 0 to 1. Yeah, but you need to make sure you put the decimal numbers 1.000, press enter, and then we should have a number slider that allows us to be more specific. And then we're going to put that into our target. Okay? Now it's really important that we take our mapped numbers and we put those as the radius instead. So we need to put our mapped numbers as the radius. And let's just turn everything else off just so we don't get confused by right-clicking and do preview off just for a minute. Let me just do this. Make sure that these are all done correctly into the right order. Turn that preview off. Turn this preview on. Set 1 point. There we go. Turn the preview on. Okay. And then what you'll see happen is our numbers should then, our radiuses should then update according to our numbers. So make sure that you've got the distance into the value, the bounds into the source, sorry, the construct domain into the target, and then we need to plug this into our radius. And then we can turn these guys off. And then wherever we move this number, this point, it will update the size of our points. But if I change the domain to be larger, so the radius of 1, that means that it's 1 on either side of my control point. But if I do it below 0.5, it means that the circles won't overlap one another. And then I've got my minimum amount and my maximum amount. So all of our radiuses now will be remapped accordingly. Did everyone's work? Did it work? Yes, the reason you've got overlapping is, if you think about it right now, the reason that this is overlapping, if we think about our radius, it's from the center. It's not a diameter, it's a radius. So if our diameter was 1, right, it would say that that's 1. Right now, the biggest size is 2. It's a radius, not a diameter. Does that make sense? Let me just very quickly show you then, in conclusion, how we'd apply this logic to our facade. So what I would like you to do is, let's just copy and paste this part here, our attractor part that you've created, which is this guy here. Yeah. And what I want you to do is, I want you to copy that, Control C. I want you to go to your definition for your tower, wherever it is. Where's my tower? Don't tell me that I got rid of it. I probably did. There it is. Okay, so with our tower, what we can now do is we can take these custom panels, we can go back to Lunchbox here. And what I want to do is, I want to introduce this one here, which is a panel frame. I'm going to bring a panel frame on, and I'm going to plug my diamond panels in. And then for my scale factor, I want to copy and paste in those guys that I've just created. So if I just go back here, or we can just create them again. If I just go here to unnamed, it was not going to allow me to copy and paste them. If it's not allowing you to copy and paste them, all we need to do is just replicate those. So we need a bound. So let's just redo it together, just very quickly. So we're going to need a distance, an attractor point, bounds, remap numbers, and constructs domain. So we'll do that very quickly. So I'm going to have a point, which is going to be my attractor point. Yep. I need a bounds. I need a construct domain, which is going to be here. I need a remap numbers, which is this guy here. And then in principle, a distance as well, yeah. So I need my distance as well. Okay, so I want you to just create those very quickly. And then the point is going to be our attractor point, which is going to go into point B. But we need to create an attractor point in our model. So I'm just going to create a point in space. Doesn't really matter where I put it right now. Just put it anywhere. I can move it up and down. So you could just put a point in space in here. And we're going to reference that as our attractor point. This is now our attractor point. Okay? I have my panel frames here. And I want to change my scale factor. But in order to change my scale factor, what I need to do before that, I need to find where the center point of each of these panels are. I can use a command called area to do that. And what area does is it'll give me the center point of some geometry. So if I plug my diamond panels into the area, it'll give me the center point of each of those panels. That's going to be where I'm scaling from. Does that make sense to everybody? So that's where I'm scaling from. And I'm going to use the centroid as the point A. Okay? And now I need to reconfigure these guys accordingly. So again, I'm just going to put some number sliders in. 1.000, press enter. Plug that in. I'm going to Control C, Control V. 1.000, press enter. So now, just following that exact same logic of our attractor definition, I want to put my distance into bounds, but I also want to put it into my value. So I'm going to do that. So my distance is going to go into my bounds, but it's also going to go into my value up here. Okay. Then I want to change my source to the bounds, and my target to be the domain. My target is the domain. And then the mapped numbers will be the scale factor, which will be here. It might take a minute for it to compute, but in principle, let's see. Right now it's set, I put in 1 and 1. So if I reduce this to my minimum number, it'll make it smaller. And if I reduce this to my maximum number, it'll make it bigger. And what you'll see happen now with these panels, if I just do a custom preview on here, I'm going to just change my custom preview. I'm just going to disconnect all of the geometry just so I can show you this. And then I'm going to put my custom preview from the panel. You'll see that my panel now has changed. Yeah. And if I move this guy up, you'll see that my panels will also change. Okay? So I've created that facade parametrically to be able to change the size of these panels according to an attractor point. Hopefully that makes sense. Does anybody not understand that or is struggling to understand it? Okay, so let me jump to clarify it. You have a question? Go ahead. Yeah, do you want to clarify? So let me just talk you through how this works. So what we're doing here is we're taking our panels, we're finding the center of them, which is going to be the point that we scale from. Then we're taking this attractor point here, which is down here, wherever my attractor is. No, it's this guy here. I think it's this one that I'm using on here. Yeah, so it's this one. And what I'm saying is, okay, according to the distance of the center of these points here to this point here, this is going to give me my distance. Now, if I was to stop there and put that distance into the scale factor, the distance is going to be huge. Let me do it so I show you. Look at the size of those guys now. The panels are now scaling according to the distance that they are. I don't want that to happen. So then I need to run my magic formula, which is these guys here. And what I'm going to do is I'm going to take those numbers. I'm going to find out what the bounds are from the first number to the last number. And then I need to remap those numbers. So I'm going to use this as my original value. This is my bounds. And then I'm going to reconstruct the domain from 0.04 to 0.9. So rather than it being huge numbers, I'm saying I want this one to be at a scale of 0.04 as the smallest number, and the largest number I want to be 0.90 to the biggest number. So it won't go beyond that. Then when I input those into my remapped numbers and I output those, so that's going to be my new target, and I output that into the scale, you'll see that the lowest possible number that I have here will be 0.042. The highest possible number that I'll have is 0.908. And it's a factor, a scale factor. So it's like the scale is 0.908 of the original panel size. Does that clarify it to everybody? Yeah? Okay, great. Now, I know that there's a lot to take in. I've gone through with you the Grasshopper interface. We've done a quick sketch of how we can create a parametric tower using some of these Grasshopper parameters. I've quickly gone through with you how to then put an attractor in there by saying, okay, according to certain numbers, a certain point in space, this is how big what I want them to be. Can you see where else you might be able to apply that or use it within your own design work? What data could you use to dictate the size of these openings? Sunlight. Yeah, perfect. So instead of using that point, what I could do is use the point as the sun and say the distance from the sun or wherever the sun is, I want it to be bigger or smaller. And you can use it in that way to apply to your own design work. And that's really quite important. Okay. So you just built your first parametric design script. Oh, it was copying it in just there. So now we've created the logic. If we wanted to put our floor slabs back in, our extruded floor slabs, we can do. And we can see those. And I could even put them into the preview as well. If I hold shift whilst I'm putting that in there, you'll see that our panels, our floor slabs are there. If I wanted to offset it a little bit more, I can do. Which is this guy here. If I wanted to offset it a little bit more so that the panels are a little bit further out, I can. And you'll see that now I have this tower that I've created. Your first ever parametric tower with fully customizable floor slab sizes, fully customizable distances between the floors, fully customizable facade system. So if I want to make more panels, I can. I can just go in here and just change the number of panels in the X and Y. So I can go there, I can increase them and make more if I want to. So this is your first ever fully parametric tower that you've modeled in Grasshopper. Okay? I'm happy to answer any more questions that people have. If you want to just stick around for a bit, then you can do. Anyone else, you're more than welcome to go and practice and have fun. But yeah, please feel free to stick around, ask me any questions that you want, and I'll strive to answer as many questions as I can. Okay? You're welcome. Thank you, everybody. Thank you for everyone for attending. Thank you. Questions? Yeah. So questions.
So with the dry panel of issue that you know that technology actually
So the tri-panels. Okay. So what we need to do is we need to create a logic that allows us to then connect those panels together as one panel, and then we'll be able to run it. So we'd have to create a logic for us to be able to do that. There's quite an extensive there's some quite extensive tutorials that allow us to be able to do that.
right now
Yeah. Yeah. I'll come and check it out. I'll come and have a look at these guys here. Does anybody else have any other questions that I can answer for the group? No? Is anybody just still like mind blown thinking, I just don't understand this at all? Or does everybody have at least a better understanding of Grasshopper than when we started today? Yeah. If you do have a better understanding of Grasshopper, then I've accomplished my mission. It's not to teach you Grasshopper entirely. It's just to help you have a better understanding of how it works and how we can use it within our design workflow. Okay. So I think that's one of the most important things. Any other questions from anyone before we conclude? Okay, thank you. Everybody online, I think we've only got one person online and they're actually in attendance here. So thank you all.